Mr. Lemansky, this is an extension to Lesson 5.7. We're going to be looking more at linear regression and what's called median fit lines. There's some vocabulary that I need to review with you first that is probably going to be new, and I'd like you to get this in your notes. The first vocabulary word is bivariate data. Sounds pretty complicated. It simply means data with two variables. When you make an XY table in ordered pairs, you have plotted or have a table of bivariate data. Might be helpful to remember the following. Bi means two. So when you see bivariate, that means two, and we have two variable data. Okay? So again, bivariate, pretty simple idea. It's just two variable data. That's a vocabulary word that our book didn't cover, but you should know. Okay? There are some other terms that are associated with the linear regression process, and a lot of these terms are newer because before we had graphing calculators and so on, we had to do this entire process by hand. Well, now that we have a graphing calculator, we can do a lot of these problems by just using our calculator and getting some data off the calculator. I want you to take great notes today because this next quiz is going to be a calculator quiz. It's not going to be something you can show your work for. It's all going to be based on calculator key sequences. I know you don't hear me say that often. You don't have to show work. This is one of those few times that would be the case. I'm going to go through a bunch of calculator key sequences that will be associated with some of the terms you're going to see here. So I would suggest taking great notes. That means maybe listening, pausing the video, taking the notes, and so on. You're going to see a few screens that I'm going to be popping up from time to time here. We're going to do data. We're going to do these examples based on this data. This is one of the test questions you had on the test you just took. It's the price of a hot dog at a Major League Baseball game. We're going to put this data in our calculator and learn some of these new terms using that data. So you'll see this screen. You'll also see the following screen, and here's some of the new information and data, or the new vocabulary, I guess I should talk about. And this will show the key sequences. Okay? So first of all, the first thing I want to talk about to start, and I'm going to take my highlighter out, and we're going to talk about something that's called the correlation coefficient, and you can see that right here. Correlation coefficient. This number tells you if your correlation is positive or negative and how close the equation is modeling the data. The closer the correlation coefficient is to 1 or -1, the more closely the equation models the data. So you might want to pause the video and get that information down. This number, again, will tell you if the data is positive or negative. If you're close to +1, or if it's a positive amount, that means you have a positive correlation. If it's negative, that means you have a negative correlation. But this number will tell me how close the equation I wrote, how close that models the data. Okay, so we're going to find the correlation coefficient for this problem, the problem of the Major League Baseball ticket stuff. Okay, we're going to use this data and find the correlation coefficient. So here's what we need to do. First of all, we need to make sure, and it's right here, we need to make sure that our diagnostic setting is on. You can find this under the catalog menu. Press D, scroll down, and click diagnostic on, then press enter. Well, that sounds pretty complicated, so let's actually do that together. Okay? So, first of all, we're going to go to our calculator. You can see with my little pointer here, I'm pointing at the catalog menu. Press second, catalog. I want the letter D because remember, we want diagnostic on. So, if you do alpha and then this key here, you can see the green D. If you do that, oh, let me do it again. It didn't pop up the first time. There I got to the D's, and then I can just arrow down. I got to find diagnostic on. There it is. Press enter again, and the diagnostic of this calculator is now turned on. Okay? Now, I got to get back to the screen. All right, so next, enter the data by pressing Stat and the Edit option. We want list 1 to be our X's and list 2 to be the Y's. So let's go and enter that data. Now remember, the data I'm talking about is this hot dog, Major League Baseball hot dog data. And let's try to reduce this so we can, there we go, that's better. Okay, so let's type this in. So in year 0, because this is when this started, in year 0 we had a $3.70 ticket price. I'm going to go ahead and hit the stat key. I'm going to edit stats. So in year 0 we had a $3.70 ticket price. Okay. In year 1, let me pop that screen up again. In year 1 we had a $3.79 ticket price. So we'll get that in there. I'm just typing these in real quick. If you want to just fast forward to this part of the video, I'm just going to type these in real quick. And I'm pretty much done here. 439 was the last. Okay, so I wanted to get that typed in. So you got to get that typed in. Okay, there's the data from the table. Now next, it says next we want to, and I didn't want this gallery. Let me get that out of the way. We want to perform the regression by pressing Stat, entering the calc, and then going to linear regression. We've already learned this in class. We can get a linear regression by hitting the Stat key, calc, and then going to linreg, which is the 4th option. Press enter twice. The only difference is you see here, we're going to see some more information. Okay, so let's go back to our calculator and do that. So I'm going to hit the Stat key, hit calc, I'm going to hit linear regression, enter twice, and this is giving me more information than I'm used to. Okay, so let's look at the information I'm being given. First of all, here's my slope. It's about 0.12. Next, my y-intercept. I'll do that in a different color. It's right here. It's about 3.7 roughly. Now, the next thing, our correlation coefficient. I want you to notice a couple things. First of all, it's positive. That means we have a positive correlation. Our data is rising. Here's the next thing I want you to notice in the correlation coefficient. Do you notice how close this number is to 1? That means that this equation is doing a really good job of modeling that data. Okay? That's how you find the correlation coefficient. And that's something I would ask. I could ask on a quiz. I could just give you a set of data, and I could say, find the correlation coefficient. All right? Next, the next slide I got to move to. Okay? We also want to be able to analyze what's called a residual. Now, let's look at what a residual is. And this is something, again, we can get in our notes. All right? The difference between the observed y value and the predicted y value, which is found in the line of best fit, is called the residual. Okay? Like in the hot dog problem that you did on the test. So let me go back to the hot dog problem. So to make clear what the residual is, let's take a look at, I took that test question, And let's just say that what I drew here is the line of best fit. The residual measures how far each of these individual points, like for example, let's take, let me highlight this, like this point, how far is that point off the line of best fit? That's what the residual is measuring. How far are these points off the line of best fit? It kind of measures how good is my equation. Is it an equation that's pretty accurate because it's meeting most of these points, or is my line not meeting most of them, which makes the line not very accurate? So how do we get that? How do we get that equation on our calculator? Or I misspoke. How do we find out that residual? Well, here's what we do. After we have that data in our calculator, we can obtain the residual plot of the data, and here's what we're going to look at when we make this plot. I'll show you how to make it in a minute. If half of the points seem to be above the line and half below the line, then we would have a line that would model the data pretty well. If all the points are on the top and nothing on the bottom, that means the data wouldn't be modeled well. Okay, so to get this, we got to do the following. We'll do this together in a minute. Oops, I want to get back to that last slide. Sorry. Here, let me turn this on so I can underline here. Okay, so first of all, to get the residual graphed, we're going to turn on plot 2 under our stat plot menu. I'll show you how to do that. List 1 will be the X list, and we'll do residual for the Y list. You can obtain the residual by pressing second stat and selecting residual from the list of names. We'll graph the scatter plot by pressing zoom and then zoom stat. So this, you might want to pause the video real quick and write down that menu. I'm going to bounce back and forth here, and let's do those. So let's go to our calculator. You see stat plot. We want to go to our second stat plot, press enter, and we want to turn it on. Okay? We want to make sure our scatter plot option is highlighted. I'll press enter to make sure. And the X's are list 1. We want the list 2, remember. The list 2, let's go back. We want that to be the residual. We can obtain that by hitting second stat and putting residual in there. So let's go back to my calculator. I want second stat, and I'm going to pick residual. So the Y values will be the residual, all right? Now, next, from there, all I have to do to graph this is press the zoom key and choose zoom stat. So let's go back, let's press the zoom key, and I want to go down to zoom stat. Actually, I'm going to go up. There it is, enter. There's a picture for the hot dog problem of the residual. You notice how half the points are above the x-axis and roughly half are below, 3 on top, 4 on the bottom. So this is telling me, according to what we just read here, that means these points appear to be randomly scattered and centered around the line, so the best fitting line is seeming to model the data well. So in other words, our hot dog equation that we already have, okay, that hot dog equation that we already have, that should be a pretty good equation, all right? So, and that was the equation, by the way, that we had earlier on. Let me just remind you of that. That was the equation that we had here, where we said, let me just write it on the screen, that y equaled roughly 0.12x plus 3.7, roughly. That would be a pretty good equation modeling the hot dog data. Okay? This is saying that the price of hot dogs increased 12 cents a year, and in the year 2009, this is on year 0, remember year 0, the price was about $3.70 is what that's telling us. Okay? Alright, so next, we got the residual figured out. How do we figure out a residual? That's the process, okay? From there, next, they talk about, you notice here, linear interpolation, linear extrapolation. I'm not going to cover that again. I think we already got that down. That's estimating points inside and outside the data. Okay, now, we can use our calculator to estimate, to do interpolation and extrapolation for us, which gets me down to where I'm at right here. Okay? We can graph the line of best fit for our hot dog data right on our calculator. So to do that, we'd press the Y equals key, we'd hit the vars key, and choose statistics. From the EQ menu, choose Reg EQ, and then press graph. So I might bounce back and forth. You might want to pause the video and write down these steps. Here's step 1, step 2, step 3, step 4, step 5. We're going to do those 5 steps right now, okay? Step 1, hit the Y equals key, and then you see the vars key. You're going to hit that, okay? Now, let's go back. Step 2, choose statistics, okay? If I go down here, I will see a statistics option. Oop, right there, I went by it. Enter. Next, EQ. Go to EQ, and we want Reg EQ, and press enter. There is the equation for the line of best fit. You can see they're very detailed, the calculator is. We rounded to 0.12. They went many more decimals past it, and we rounded to 3.7. Now, from there, we would like to graph it, so all we have to do is press graph. And if we do that, oop, one thing I should change, we don't see the line because our window is screwed up right now. Let's go to zoom and standard, option 6. Okay, there would be our line of best fit. Okay, you can see if you go 1, 2, 3, 4 units up, 370 was the correct price of a hot dog, so at 0 years, 370 was the price, and it's slowly growing. Okay, I see these other points from my residual problem still on my screen. I'd like to get rid of those. To get rid of them, let's go back to the stat plot. That'd be second stat plot, and let's go back and click back on plot 2. Just turn it off. You press enter, we'll turn it off, and now go back to graph, and you notice we don't have those points in there. Okay, so there's the line of best fit. And we said we want to predict other values. So I'd like to predict the value of hot dogs, let's say 8 years after the year 2009, okay, 8 years later. So in 2017, I'd like to know the hot dog price, okay? To do that, it shows right here what we need to do, right on this step right here. And just a second. So to get that on your calculator, you can see that right here. I'd like to predict, I said 8 years after 2009. All I have to do is hit second, calc, enter, 8, enter. Okay, so let me do that. So I'm going to go to second, calc, okay, enter, enter, 8, enter, and what this is showing me is right now it just jumped. It said that, okay, 8 years after 2009, let me freeze the screen. So in the year 2017, that would be 8 years after 2009. I should just put actually an 8 in here, because it'd be 8 years later, that's 2017. The price of hot dogs looks like it's going to be about $4.66 a hot dog at the current rate. That's what this is showing us, okay? So we can always we can extrapolate or interpolate by doing that. Let's say I wanted to find, let's do another one. I want to find 20 years later. Second, calc, enter, 20, enter. Okay, oop, I'm getting an error message. I got to increase my window. I got to zoom out. Let's zoom out. because that was going off the screen. Let's zoom out a little bit. Okay, let's try it again. So I want second, calc, enter, 20 years later, enter. Okay, this is showing me that in 20 years after 2009. So in the year 2029, according to this data, I could predict that hot dogs would cost about $6.11 at the Major League Baseball games. Okay? Finally, one last thing, and we'll stop the video. We also want to be able to find what's called a median fit line. It's similar to the line of best fit, but a median fit line, and you can see here, a median fit line is an equation is calculated, it's a median fit line, it's calculated using the medians of the coordinates of data points. So remember what median means? Median, remember, is the middle number in the group. So if you put your numbers from greatest to least, the middle number in the group would be considered the median. All right? To go ahead and to find the median fit line, we just have to do the following. Hit the stat key, calc option, scroll down to median option, and press enter, and that will show me the slope and y-intercept of the median fit line. Okay? So pretty simple to do, so let's do that. So I'm going to go to the stat key, calc option. You can see instead of linear regression, we're going to do a median fit line. Press enter, enter, and you can see this equation is really close to what we said originally. We said it was y equals 0.12x plus 3.7. The median fit line is very close to that. In fact, here was the line of best fit up here. Right up here, I'm going to circle it. That was the exact line of best fit. You can see it here. You can see the median fit line is pretty close to that. Okay? I think that's where I'm going to end the video. So those are a few tasks that I would want you to be able to do. Obviously, there's some calculator key sequences that we have to remember to get that done. That's why I said I'd let you keep the notes and use them. So I hope you are taking good notes so that if I ask you, hey, write the median fit line for this data, you'd know the key sequence to be able to do that. Or if I said to you, let me go back, if I said I would like you to use your calculator and extrapolate, in 20 years, how much is the cost, that you'd be able to do this process here. All right? Or the residual. We should be able to put that on our calculator and see, do the points seem to pattern or to fit the data well. Okay? So those are the type of things I'm looking at.